Hello and good evening everyone. Thank you for joining me in today's session. So today in this session we are going to begin this project, C functions and also nested loops. So before everything we need to first understand what a function is and also what a nested loop is as well. So a function is simply a collection of code that is used to solve a specific problem. Okay, that is used to perform a specific task. For example, let's say you have a program, or inside your program you want to write a function that will add two numbers, right? So instead of you to always be writing the code that will find the summation of these two numbers every time you want to use it, you can just write a function whose purpose, which purpose of the function is going to be what? Simply adding these two numbers. So anytime, anywhere in your program you want to add two numbers, you just simply need to call that function, since that function is responsible for adding two numbers. So you just call the function and say, hey, perform this summation for me, and then the function will perform the summation and it will display the result for you. Okay, so I'm just trying to give you an insight of what a function is. So like I said, function is just a collection of code that is used to solve a particular problem. So you can write a lot of functions in your program. So a common example of functions is the int main function that we've been using in our C program. Okay, yeah, you know that whenever we write our program, that int main function is a must. Right, you need to have that main function for your program to compile without any error. So that is also an example of a function. So let me just explain this here. So how do you create this function? So to create a function, the first thing you need to do is you need to declare, or you need to tell the return type of that function. For example, I said, let's say I want to add two numbers, assuming 1 and 2. Right, you know that these are counting numbers, not floating numbers. They don't have any decimal point, just 1, 2, 3, 4, 5 counting numbers, right? So let's say I want to add numbers, and these numbers I want to add has to be one of these counting numbers. So you know that it cannot take float, right? So definitely if I'm to add any two numbers from the counting numbers, it is going to return what? An integer. Right, if you remember your data type, that is an integer because it doesn't have what? A decimal. Since it doesn't have a decimal, it means it is an integer. So it means my function is going to return the summation, right, which is an integer. So the first thing I need to put here is what? Is int. So this int is telling the function that, okay, I'm expecting you to return an integer value. Do you get it? If it is a character value, you need to pass in what? Char here instead of int. But here I'm using int because I've already give an example of what? Of int, right? So the next thing is you give your function a name. What is the name of your function? In my own case, let me call it add, since it's going to what? Add two numbers. So now my function name is add. So anytime I want to call the function, I will call it by this name here, add. Okay, so the next thing is what? The next thing is you need to specify how many parameters your function is going to take, including their data type. So my function is going to take two parameters, like I said, because I want it to sum two numbers, right? So it's going to take two numbers, and all these numbers that it's going to take, what is the data type? It is an integer. So I would just say int, and then let me just give the variable a name, any name. You can give it any name. Okay, so int a, and then what? A comma here, and then int b. So it means that it is going to take two integers, each of what? It's going to take two parameters, each of type integer. Do you get it? So inside here, now this is what the definition of the function. So inside, or here, you need to open a curly brace, and inside this place here, you need to define how the function is going to work. So in my own case, I want to add these two numbers. So I will just say my function should return what? I'll just say return a plus b. So what it's going to do is that whatever is passed to this function as this first parameter and whatever is passed as the second parameter, the function is going to sum them and it is going to return the value. So that is why I said it is going to return what? An integer, int here, because a plus b must be an int because the parameters that we are summing are all integer. right? So then you close this here. So this is just a simple declaration and also definition of a function. Okay, so one thing you need to understand here is this portion here, this part here, this is called the function prototype. Okay, it is called the function prototype. And for you to write any function, you need to declare the function prototype. Just like the way we normally declare any variable before we use it, right? For us to use any variable, let's say ij, we need to say int j or something like that. We need to specify the data type, right? That is declaration. So you need to declare your function as well. So this is what you need to declare now. This is called the function declaration or prototype. It is mostly called the prototype. So it's the same thing as the declaration of the function or the function prototype. So any function in this format, its prototype is simply the return type with the function name and also the parameter that the function takes. So in our own case, this is our prototype. Let me rewrite this. So it's going to be int, right? Then add, then in bracket int a comma int b. But in this case, since this is a prototype, you need to add what? A semicolon at the end. This makes it a prototype. So for you to use any function, for you to write any function, you need to do something like this. You need to declare this. Do you get it? So the declaration of this or explanation for the on how to declare this brings us to what is called the header file. So where is this declaration taking place? Where do we need to declare this variable? Sorry, this function here. You can't, or it's not right to declare this variable inside your what? Your main file. So the best way to do this is to declare this variable in another file which is called the header file. The header file ends with what? A .h extension. So any file you see with a .h at the end, it means that that is a header file. So one of the uses of the header file, there are a lot of uses actually of the header file, but for now we are going to focus on this. One of the uses of the header file is simply declaring the function. So this function prototypes you are seeing here is going to be placed inside our header file. Okay, like I said, it's not proper for you to write it or to display it inside your main file. So the best way to do this is to take it into that .h file, which is called the header file, and you put the declaration there. So inside your main file, you now include it. Don't worry, if you don't understand what I'm saying here, we are going to see practical example on how to do that. So here I'm just trying to give you an idea of what this is. So this is the prototype, and I said we are going to paste this in what? Our header file, right? So let's do this on the terminal. This is my terminal. Let me zoom a bit. So let me just create a file. Let me just call it tests.c, right? So the first thing we need to do is hash include stdio.h. This is what? A declaration, right? A simple declaration of stdio.h. So this is what? .h extension, right? Sorry, yeah, a .h extension. It means this is a header file, right? I've already explained this when we're talking about the first project, right? We've already explained the stdio.h header file. So what's the next thing we need to do? So here I will just say int main. This is an example of what? Of a function here. So void, it means that whenever you see this void, it means that the function is not taking any parameter. Okay, so here as well the return type can be void. Instead of int here, it can be void. This means that what? The return type, the function is not going to return anything. So anywhere you see void in place of this, it means that the function is not going to return anything. Okay, that's just what this is trying to say here. So I have this, or before this, let me create my function. Let me just say hash include, let me call it main.h. Okay, I'm going to create my header file called main.h. I'm just trying to explain to you what the header file is. So here I will now declare my function int add, right? Sorry, define the function. I said it's going to take two parameters and also int b here, right? So here I will now define how the function is supposed to work. So I will just say the function is going to return a plus b, right? That's how the function is supposed to look like. isn't it? So I will now create the header file now. So let me call it main.h. So inside this header file, like I said, this is where we need to paste the prototypes of all our functions, right? But before that, there is something we need to do in any header file that we create. We need to guard the header file. Okay, so there is something which is called the include guard or the protector of the header file. So what this does is simply it prevents double inclusion of the header files in any of your program. Okay, so the first thing we need to say is hash if not defined. That's what this means. So if not defined, what is our file name here? It is simply main.h, right? But in this case, you are not going to write main.h. Anywhere with dot, you just add underscore with h here. Okay, as you can see, everything here is in capital letter. So just put it in capital letter. So this name can change. But the reason I'm using main.h here is because it is more descriptive, right? It is more descriptive because the header file name is what? Main.h. So if I do something like this, I think it is more descriptive, right? So I have this now. If not defined, main_h. So what this is going to do is that if this main_h is not defined in any function, oops, what did I do here? Okay, if this main_h is not defined in any program, so it is what? Going to define it. So it will jump to this part here now. Define. Sorry, I'm supposed to say define. Wow. Define. Right? So I'll just say main_h. So if it is not defined, right, in any file, if the main.h is not defined in that file, so it will jump to this part and define it. If it is already defined, then there is nothing to do about it. So this way we are going to prevent double inclusion, because without this, there are cases that you will include your header file multiple times in a single file. So when you do that, the prototype, or there will be different, or there will be declarations of variables or whatever, it will happen a lot of times, many times, right? Because you are including it how many times? Assuming you're including the other file 4 times. So there will be variable declaration. Let's say we have structures, they will declare structures 4 times, all these things. So to avoid all these errors, that's why we need to do this here. Do you get it? So, and here we now say end if, so not in caps, sorry. So end if. So for you to have any header file, you need to do this thing. Okay, you need to do this thing. So the next thing we need to do, like I said, is to add our function prototype. So what is our function prototype? It is what? Int. Don't forget the function I just wrote. Then it takes in what? 2 parameters, int and int. So if you like, you can add in the variable just like the way I did in the definition. And also, if you like, you can remove the variable name that is inside this header file. But you can't do this when you are defining the function. But when you are declaring the function, you can do this. Okay, so here you add a semicolon. So that's it. So let's end this. So the next thing is I will just create a file, or let me just do this inside the same test.c file I created above. I'm just trying to explain the concept here. Okay, so here I will just say, let me just call my int main function here. So void, right? So inside this int main function, I'm going to call my function now. What is my function name? Add, right? So I'll just say add. So assuming I want to, let's say I want to add 5 and 2, for instance. So I'll just say 5 and just say comma 2 here. So that's all. So I'm expecting this to return the value 7. Okay, when you look at this, I call the function by its name, and the function takes in what? 2 parameters. So I pass in the parameters here, and also I created a header file in which I pasted this function prototype there, right? So now let me just compile this. Let me just say gcc test.c, right, -o, right? So let me just call it t, for instance. All right, so let's run this. Okay, sorry, I need to say here, let me just use printf. So I'll just say printf is because here I did not say the answer should be printed. I just say it should be returned. Okay, I just say it should be returned. So I need to use printf to print the value. So here I will just say printf. So I will just say %d, since I'm printing what? Decimal, right? since I'm printing decimal. So here, yeah, so I think it should work now. All right, so I think this should now work. This should print 7 for me. So let's compile again. GCC, what happened? Okay, I use printf without including the library, so I need to say hash include here stdio.h. This is the standard library for the printf, right? I'm sure this is not something new. All right, so let's run it. So did you see I got the value 7, right? So I'm able to write a function now that will sum up 2 numbers, right? So let's say I want my function to take 3 variables. So I'll just come here and say comma int, let me call it c. So from here I will now pass in another variable, let me just say 3, another parameter. So I need to go and make corrections inside my header file, right? So I will just say main.h. So here I need to tell my header file that, okay, expect what? Sorry, my prototype, expect another parameter of type int. Okay, so let's compile this again and let's see. I'm supposed to get the value 10 now. Sorry, did I miss something? Did I compile? Vi int, each of type int, like I said. Sorry, seems like I'm missing something somewhere. Int add, int a, int b. Okay, here I need to add plus c, right? Plus c. Now I have 3 parameters. So I'm expecting this to return or to print how many? To print 10. So let's see. So did you see that? Now I got 10. So this is simply how to write a function. Okay, this is simply how to write a function. So function is used to what? To kind of solve a particular problem. So anytime now I want to add 2 numbers or 3 numbers, I just need to call the function add and then pass the parameters to it. So as you can see, this has eased some work for me, right? So that's just the work of what? Of a function. That's just what a function is. Okay, so here the next thing we need to talk about is the nested loops. So a nested loop is simply a loop within another loop. We've seen loops when we're talking about conditional execution, that is the if else, right? We've seen the while loop and also the for loop. So a nested loop is just a loop within another loop. Today we are going to solve examples on this particular project, functions and nested loops. That way you'll be able to understand more about functions and also nested loops. So before we continue, as you can see here, I'm working on my Vagrant. When you look at this, I'm working on my Vagrant. So there is no need for me to be adding, committing and pushing always all the time, but I will make sure my code is standard, and also we'll be running Betty checks on this as well. So if I run Betty and Betty is fine, then I'm sure this code will also run when you this code will also pass when you click on your checker. The checker will also pass this this code here. So let's begin this task here. So before that, I seriously recommend that you should go through the material first. That way you'll be able to understand more and more about the concept before you begin watching this video or solving examples on this or solving this project here. Alright, so before we do anything here, the first thing we are going to do is we need to copy this putka here. Actually, putka, I've explained it when I was talking about Hello World, right? The first project. We've talked about putka, we've talked about printf, we've also talked about puts, right? We've talked about them. So, but as you can see here, this putka here is a bit different from the standard library putka. This one has an underscore, and that of the standard library has no underscore. So they just created this underscore to differentiate it from that of the standard library. So now we are going to copy this putka here. We are going to be using it. So the first thing we need to do is click on this link to open the link. So when you open the link, the next thing you should do here is simply copy the file, right? This entire file here, this entire code. So when you copy it, you simply come here. I'm working on my Vagrant, so I will have to navigate into the directory first, ALX low level programming, then I will now cd into 0x02 functions and nested loops. So this is the file in which I'm currently working on. Okay, so here I will just say vi, I will name it putka.c. Alright, so I will just paste it here. So now I have it pasted. So if you can remember, I said any function we create, we have to store its header file its prototype inside our header file. So I need to copy this now. So I will now take it to the header file. So I will just say vi main.h, that's my header file name. So I need to guide it. I've already explained what include guide is, right? So if it's not defined, main_h, then hash define. This is done to what? To prevent double inclusion of the same function, right? Or the same header file which contains function prototypes. So then hash and if, right? So here I will just paste this. So end it with a semicolon. So now I have the function prototype for our what? For our putka, right? So that's the first thing we need to do. So now let's begin solving the examples. So when you look at this question, it says we should write a program that prints putka followed by a new line. So the program should print putka and what? Followed by a new line. So what I'm going to do here is I'll just first copy this. This is the file name. So vi paste, this is the file name. So what's the first thing I need to do? I need to include what? My main.h, because it is the file that is containing the function declaration, that is the function prototype of what? Of this putka in which I want to use here, right? So putka, when you look at this, I'm adding it in what? In a within a what? Double quote here, main.h, like this. It is within a double quote. Why is it within a double quote? I think I've already explained this in the previous video when I was talking about hello world, when we were talking about C compilation processes. We said the reason why we are using a double quote here is because this main.h file is in the same directory as the file in which I'm currently working on here, right? Unlike that of the stdio.h, where we use an opening bracket which is a less than and also a greater than, right? And then within this less than and greater than, we put our what? Our standard library header files, stdio.h and what have you, right? So but in this case, since our main.h, we are the ones who created it and it is in the same directory as the file here, this file in which you are going to write on, then that's why you need to add it within what? A double quote. So all what this is saying is that preprocessor, don't go and look for this file in any other directory. Instead, look for it in the current directory we are working on. That's just what the double quote means. The ones with the triangle, with the greater than and less than sign, is just saying that preprocessor, don't look for this file inside this directory I'm working on. Instead, look for it in other directories apart from this one. That's just what this means. Okay? So now it says what we should write a program. So I'll just say int main. Here they said write a program, not a function. That's why I'm saying int main. So this is also a function, and this function here is a must in any C program. It is a must. If you don't have this main function, then your program will not work the way it's supposed to work, because your preprocessor or your compiler first looks for this main file before executing any other function. So it is a must. Okay, so here we are going to what? We are going to write a function that is going to print this putka here, putka like this. So the program should return what? 0. So in this case, you are not supposed to use a printf. You are not supposed to use a standard library. Okay, you are supposed to use what? Putka here to print what? To print putka. So the first thing I'm going to do is I need to call my function putka, the one we just created, in which its responsibility is simply to create characters. I've already explained putka, right? We've explained putka when we're talking about compilation processes. We've explained what putka is. It is used to print characters, right? But in this case, ours is what? Is performing the same operation as that of the standard library, but ours has what? An underscore here. So if I remove this putka is that of the standard library, and it will work exactly the way our own is supposed to work. So just to differentiate it, that's why we add an underscore here. And a function has already been created for this. So we just need to call the function putka, right? So here, what is the first thing I need to print? I need to print the underscore, right? Just look at this. It is the underscore first. So I will just print underscore here. Then I will now call the putka again to print what? Putka to print P, right? Then I will call the putka again to print what? Putka, sorry, not in caps. So I'll call putka again. In this case, it's going to print what? Let me just copy this to avoid copying all the time. Yeah, so putka, sorry, copy, yeah. So this is going to be putka what? U here, right? And then paste this here. So here I will just add a T, right? So paste here again. So here I will just add what? A C. As you can see, we are spelling Putka, right? So if you use printf, you can use printf to print this at the same time, but in this question your checker will not check if you use printf. Okay, so Putka, then I have my A here, A, right? Then here I think that's all right. We've spelled Putka. So at the end they said what? Ending with a new line. So you have to end this with a new line. So I'll just call Putka again, and then I will pass /n. This is for a new line. So this space you're seeing here doesn't mean anything. If I like, I can just do something like this. Maybe I should do it this way so that you guys will not be confused why I left the space. It will still work like this, right? So now I have this. So let's compile this program. I'll simply just copy this command here. Or before that, let's run Betty. Let's run Betty on our file. Okay, we've not even done Betty documentation, I think. So what we're going to do here is simply document Betty. So all what Betty wants is what Betty wants is that you should just explain any function and any parameter used in that function. So in this case we are using the main function, right? So I need to tell Betty, right? So here I need to say return 0 at the end. I'll return 0 here. So I'll just say return 0. So let me explain to Betty what this function is. So you first start by a / and then asterisk, then go to the next line, right? And here you pass in main, that's the function name, and then when you pass in main you add what? A dash, right? So then you explain what the main function does. So here I'll just say function, right, that prints Putka. I think that's all right. Then what again did we use? We've not used any parameter, so I'll just explain the return value now. So note that when I'm explaining the return, I use the capital letter R. If you use the small r, it will not work. Okay, so in this case, if you explain the return value, you will simply use what? A full colon here. Okay, unlike if you're explaining a function. If you're explaining a function, after the function name it is a dash, but in this case if you're explaining something like return or any parameter a function is taken, it should be a full colon here. Okay, so now I'll just say what the return does. So returns what does it return? Returns 0. So here on the new line you simply close it with what? A / as well. So this is Betty documentation. So let's explain this, or let's run Betty on this. So 0. Yeah, so as you can see, Betty is happy with this. So there is no error here. So now we can proceed to compile. So let me paste this. Oops, I think I copied. All right, so let me paste here. I think that's all. Did we miss something? Okay, I think in the Putka, yeah, I missed the #include here. Sorry, #include. All right, so I think this is okay now. So paste this. So as you can see, I'm compiling including what? The underscore putka.c. If you don't compile including it, it will give you an error. This is the file that contains the function definition of Putka. Okay, and this is the file we created, and this is the new name we are giving this file. So to run this program, we are simply going to call it by this name here. So I'll just press enter here. So as you can see, it's compiled, right? So I just say full stop /, and then what is the name that we give the compiled file is 0 Putka, right? So I just say 0 Putka. So as you can see, I'm now calling it, right? Sorry, I'm trying to run the program. To run the program is a full stop and then /, and then what? The file name. So press enter. So as you can see, we got Putka printed, just like the way it is printed here. We have Putka here. So this is what? This is simply how you can do this. Okay, so now you can add, commit, and push, and you can push to your and you can run your checker. I'm certain this is going to work. Okay, so let's move on to the next task. So before that, we need to copy the function prototype here, and we need to take it to our header file. Don't forget, if you don't add your your prototype in your header file, your checker will fail. So it is a must that you need to have this in your header file. Okay, so let me just zoom my screen a bit. Yeah. All right, so let's move on. It says what? We should write a function that prints the alphabet in lowercase followed by a new line. So let me first copy the file here. Copy. So vi paste. So what's the first thing we need to do? We need to include our main.h because our prototype is defined inside our what? Main.h. So main.h. So here, as you can see, they said write a function. So this is the function prototype we've been given. So I'll just paste the function prototype. Sorry, not the function, not the file name. So I'll just copy the function prototype again. We are going to define our function based on this prototype given to us. So here, so I'll begin writing. So it says we should write a program that print alphabet in lowercase, followed by a new line. And what? This is the function prototype, and they've given us an instruction that we can only use the underscore putchar function twice in our code. Okay, so definitely we are going to use a loop in this case. We've already explained loop when we're talking about conditional execution, right? So we are going to use loop here. Since we are going to what? We are interested in getting information, or let me say in getting data from a certain range. We know that we have 26 alphabet from A to Z. So definitely we cannot exceed what? 26, or we cannot print less than 26. Because that's what it says. We should print the alphabet in what? In lowercase followed by a new line. So I need a loop that will loop over the entire 26 alphabet. And for each iteration of the loop, I want to print the current value or the current data. Do you get it? So the first thing I'm going to do here is I'm going to use a for loop. Okay, so I need to declare the variable I'm going to use for my looping. I'm going to call it I here. Okay, I'm going to call it I, or since I'm printing character, I'm printing character alphabets, right? So I will call this car here instead of I. So this means that what I'm trying to loop is what is a character, right? So I'll just say for I equals to what? I need to initialize I. Where do I want my loop to start from? Since I'm printing alphabet entirely, I will start from what? A. I'm starting from A. So I'll put A in a single quote. Take note, since A is a character, you need to put it within what? A single quote. Okay? It is a character, so it needs to be within a single quote. So for I equals to A, I'm sure you understand what a character is because this has only one character here. If I should add B here now, this is not a string. So you cannot use a what? A single quote within a string. So I need to remove this now. So this is a character because it contains just one alphabet or one character or whatsoever. As far as it is more than one, it has become what? A string. So I need to start from A, right? So that's why I did something like this. Take note, I'm leaving a space between the I and also the equality sign, between the equality sign and also the character. If you don't leave the space, Betty will fail. Okay, so now I have this. So in what condition is this loop going to stop? Because you need to set a condition to stop the loop, right? So I want my loop to keep running until it reaches what? Until I is what? Until I is less than or equals to Z. So the moment this condition is false now, that is the moment I reaches Z, it is going to what? Stop the loop. Because as you can see here, I've targeted what? A to Z. Sorry, I need to put my Z within a single quote as well. This is a character. So all what this is saying is that start the loop from A. And also the loop should keep running until what? My I is less than or equals to A or equals to Z. So the moment my I becomes any other value apart from Z or apart from any other value less than Z, then it is going to stop the loop, right? So what should happen? After each iteration, what should happen? We are going to increment the value of I. Since we're starting from A, after the first iteration, which is A, then we need to increment the value of I to go to where? To go to B. After B, increment it to go to C until this condition becomes false, right? So for each of this iteration, what do we need to do? I want to print what? The current value at that position. So the first iteration, A is given. Sorry, for the first iteration, I is A. So I need to what? I need to call putchar to print the current value at that position. So I'll just say underscore putchar here, and then I'll just say I here. So all I'm saying here is that for the first iteration, I is A, it will check. Is that particular A less than or equals to Z? Yes. A is less than or equals to Z. So it means this condition here is true, right? So it will now print what? The value of I. And what is the value of I? A. So it will now increment the value of I from A to what? To B. It will now check. is B less than or equals to Z? Yes, B is less than or equals to Z. We know that. So it is going to jump into the loop, and it is going to print the value of I at that position, which is B. Same as C, D, up to what? Up to Z. When it reaches Z, if it checks this, it will say, okay, yeah, Z is equals to Z, and it is part of the condition we set. So it is going to jump into the loop. So if it increments, we don't even know where it is going to increment to. I don't even know. We know that the last alphabet we are checking for is Z. So whatever it increments to, this condition will not be true. It will be false. So it will exit out of the loop. So as you can see here, I'm leaving a space here. Right? It doesn't matter if you are adding just one line of code inside your for loop. It doesn't matter if you put something like this. If you like, just leave it without this curly brace here. It will still work, as far as it is just a single line of code you are putting inside. So the reason why I neglect the curly brace here is because I'm adding just one line of code inside my for loop. So now I'm done with my loop. So the next thing is what they said, we should only use putchar twice, and we are going to what? Followed by a new line. It should be followed by a new line. So after printing all this from A to Z, definitely this loop is going to print from A to Z in lowercase. So after printing from A to Z, what should happen? Just look at their own output here. Then it should go to a new line, right? So I'll just say putchar, that is outside the loop. When the loop is done, print a new line. So I'll just say /n. So now I have this. So what's the next thing? We need to document Betty now. We need to tell Betty what this function is. So the function name is what? Is print underscore alphabet, right? So you don't need to add this void, just the function name. That is this part here. That's the function name. That's what you need to call. So here I will just say function to print alphabet, right? In lowercase. I think this is okay, right? So then we need to explain to Betty the return, right? So I will just say, even though return is not here, you need to explain to Betty. You need to tell Betty, okay? You need to tell Betty. If not, it will tell you that you've not explained the return value. When you look at this function is void. So it means that it is not going to return anything. It is void. So that's why I don't have a return here. I've explained that when you are writing a function, this part here is the return type, is the data type of the return value. So this function is not returning anything, right? So I will just say, what should I say? Let me just say 0. It's just returning 0. It's not returning anything. So here I will just close this. So now I've what? I've documented Betty. So let's test this. Sorry. So Betty, this is the file name. Oops. So as you can see, it says we have trailing white space and also trailing white space in what? Line 11 and line 15. So let's check this line 11 and line 15. So I will just type in this command, set number. That is before pressing your I. Let me just do this again. So I open the file like this, right? So don't press anything, just press in the word, the full colon, and then set number here. So what was the line? Line 14 and line 15 says trailing white space. So let's check. Let's see the space. Is it line 14? Wait, let me check which line. Okay, line 11 and line 15. Yeah, line 11 and line 15. Set number. Line 11 and line 15. Okay, so let's see the space. It says, yeah, definitely there's a space here, so I need to remove it, right? I just moved my cursor and I realized that there is a space. So as you can see now, I'm trying to move it to the right. It's prompting, it's just doing that beep. It means there is no way it will go to. So line 15 as well, yeah. As you can see, as I'm moving my cursor, it is moving. So it means that there is a space from this point to this point. So I need to press backspace. So as you can see now, it is not moving. So I've removed the spacing. So let's run Betty again. So as you can see now, Betty is happy with this, right? So that's just what Betty wants. Don't leave a space. Also, there are a lot of rules about it. Just follow the instruction, the documentation on Betty. You seriously get this. Or you can just keep following me in this tutorial. You'll also be getting what Betty wants from you. Okay, okay, we've not created the main file. So let me copy this. This is the file in which we are going to use to test if our function is working correctly. As you can see, this print alphabet is where the function is being called, right? So I need to say vi1 main.c. That's the file name, right? did you see that this is the file name 1main.c? So I copied the file and then I'm pasting it here. So this is going to be used to test if our function is working the way it's supposed to work. So here I'll just say hash include. Alright, so now let's run Betty again. Sorry, not Betty, let's compile. As you can see, it has been compiled now, right? So let's run the compiled file. That is full stop / and what is the name we gave our compiled file? 1alphabet, right? So it's going to be 1alphabet, then press enter. So as you can see, we are having A to Z. Completely, we are having A to Z. So this is simply how you can write this code. Okay, so don't forget to add, commit, and push to your GitHub repository and run your checker. I'm sure it will work. If it doesn't work, just let me know in the comment part of this video. So like I said, we are going from this example here. We're going to continue from here. So first, let me copy this function prototype and let me open my main.h. Right, then I'm going to paste this here. Right, so paste, then save and exit. Then what does the question says? Let me copy the file name first. See, so vi, open the file. All right, so what's the first thing we need to do after opening the file? We need to say hash, right? We need to include our main.h, which contains our function prototypes, main.h. Then there's the function I'm writing now, right? So copy this and then paste. All right, so this question here says we should write a function that prints 10 times the alphabet in lowercase, followed by a new line. In the previous example here, we just printed the alphabet in lowercase, right? But in this case, we are printing it 10 times and also in lowercase. So this is an example of a nested loop. This is going to be a loop within another loop. So I'm going to create 2 loops for this. The first loop is going to keep track of how many times my A to Z is printed. So it is going to keep track of what? Of the 10 times that the alphabet should be printed. While the second loop is going to print the alphabet itself, just like the way we did here. We created a loop to print this alphabet, but only once, right? But in this case, we are going to need a loop to print the alphabet how many times? 10 times. So I need a loop to iterate from what? From 1 to 10, and also I need a loop to iterate from A to Z. So that's where I'll be able to print A to Z how many times? 10 times. Right? So now the first thing I need if I'm going to create a loop is I need to set the variable in which I'm going to use for my iteration. I'm going to use a while loop, sorry, a for loop as well here. So the first thing I would say int I, I'm going to use this for what? For looping over what? 1 to 10, right? And then the next one is I'm going to use char G. Now this is going to be used to loop over the characters, the alphabet. Right? So when you notice this, after this function declaration, I'm leaving a space here to begin my for loop, right? So if you don't leave a space here, Betty will give you an error. So after every declaration, you need to leave an extra space before you begin writing your main code. If I should not leave the space here, let's say I did not leave the space here, I'm definitely going to get a Betty error. So let's do it. So I'll just say for the first thing I need to keep track of is the number of times, right? So for each iteration, I want to print A to Z. So I say for I, I'm starting from where? From 1, right? Or you can say I equals to 0. Anyhow, you can start from 0, but what should be your condition? I'm printing it how many times? 10 times. So it should be I less than what? I less than 10. Why am I using less than 10? Because you know that I'm not going to include 10 in this case because I'm starting from 0. If you count from 0 to 9, that is when you are going to get what? 10. Just count 0, 1, 2, up to 9, you're going to get 10. If you say I less than or equals to 10, it means you are having what? 11. If you want to use I less than or equals to 10, you can simply change this to what? To 1. So this is going to be 1 to 10, right? That way you have 10 numbers, right? 10 digits. So here I need to remove this since I'm starting from 0. Anyhow you do it, it's going to work, right? Then what again? Then I plus plus. So I need to increment. So inside this loop here, right, inside this for loop, I need to what? I need to create another loop. So it means that for each iteration of I want to print the alphabet A to Z. So now I will say for J equals to what? In lowercase, right? So I need to add this. I'm sure you must have been familiar with this. This is the same example we did. So J less than or equals to Z, right? Then J plus plus. So notice how I'm doing my own. If you are not leaving the space between the equality sign and these characters here, and also this and this, Betty will give you an error. So you need to take note of where I'm leaving my spacing. Okay, so now what next? So here inside this for loop, I will just call my putchar. I will just say putchar, and then putchar will print the value of g for me. So all what this is going to do is simply the first iteration for I, which is 0, it will check, is I less than 10? Yes, I is less than 10. That is 0. 0 is less than 10, so it will jump into this loop. We know what this loop is going to do. We've seen how to use this loop in the previous example. So it will jump into this loop because the condition here is true. 0 is less than 10. So when it jump into this loop, it is going to print what? A to z. Right? After printing A to Z, then it will increment the value of I here again. So when it increment the value of I is now what? 1. So it will now check, is I less than 10? That is 1 less than 10? Yes, it is true. So it will now jump into this loop again. So this loop will also print A to Z again, from A to Z. You see now we have how many? We have A to Z appearing twice. So it will now increment the value of I again to what? To 2. Right? It will check, is 2 less than 10? Yes. So it will jump into this loop again and print what? A to Z. How many times? The third time, because 0, 1, and 2. That's how it will keep going until this condition becomes false. Right? So the moment this condition becomes false, it will exit out of this loop. So what are we going to do when it exits out of this loop? We are told that it should follow a new line, and we can only use putchar twice here. So here I will just call putchar for my new line. So I will just say putchar, and then I will just say /n. So you see with this, I now have what? Putchar, a new line, printed on a new line. Do you get it? So now I have putchar printed on a new line. So let's test this and see. So before that, let's run our Betty. Let's document Betty. So here, right? So what is the function name? Print alphabet, right? Alphabet underscore x10. That's the function name. So let me explain this. Print alphabet, right? Alphabet lowercase 10 times. Let me just do something like this. So it has no return value, right? So I'll just say return, just say 0. So this and this. All right, so let's run Betty on this file. This is to print something. Okay, so it says missing a blank line after declaration. You see, this is what I was telling you. After declaring any variable, right, you need to leave a space. Okay, you need to leave a blank line. If you don't leave a blank line, Betty will give you an error. So as you can see, it was initially like this for loop here. It was initially like this, right? So I need to press enter to give a space here. Do you see? Now I have a space. So let's run Betty again. So as you can see, Betty is now happy with this. So let's create the test file, which we are going to use to test if the function is working correctly. So I will just say vi, that is 2main.c is the name of the test file, right? So I will just paste this here. I don't know why whenever I copy this, I have to add the hash I here. All right. So now let's compile the program. So let me copy this. Let's paste. All right. So what's the name of the file? The name of the file is what? 2alphabet_x10. Okay. Seems like I left something somewhere. No, not Betty. As you can see in my 2main.c, it says I've added an extra character somewhere. So let me fix it. Okay, yeah. Here, when you look at this, I added I here. So it's not supposed to be here. All right. So let's compile again. So as you can see, it has been compiled. So let's run the compiled file, which is 2alphabet. So let's run it. Whoa, so as you can see, it is printed, but it is kind of jam packed in one place. So it seems like our spacing, we've placed our spacing in the wrong place. Sorry. What we are supposed to do here is this putchar here is not supposed to be here, because when you look at this for loop entirely is responsible for what? For printing the alphabet. So after printing A to Z, just look at this. After printing A to Z, move to a new line before incrementing the value of I, right? Before printing the next set of A to Z. So this is where our new line is supposed to be. So putchar here, and then /n. So with this, problem is solved. So let's compile. So let's run the compile file. So as you can see, we have A to Z. How many times? 10 times. Just count this. You're going to get 10 times. Okay, so now let's move on to the next steps, but before that, don't forget add, commit, and push to your GitHub repository, and then you can run your checks. If there is any error you're having, you can drop it in the comment section of this video. All right, so this task here, before that, let me copy the function prototype. I like dealing with the prototypes first because I hate opening the main.h all the time. So let me just paste this. I missed an I here. All right. So what's next? We need to create the file, which is this 3islower.c. Copy it. So what's the first thing we need to do? We need to include our main.h because it contains the function prototype in which we are going to work on now. So copy this. So now we begin writing our function. All right, so the question says we should write a function that checks for lowercase characters. So the function should just check for lowercase character. When you look at this is the return type of the function, and this is what? This is the parameter that the function is taking. It is taking an integer c, right? So we should write a function that checks for lowercase character, and this is the prototype, and returns 1 if c is a lowercase. It means that if the parameter passed to the function is a lowercase, the function should return 1. Otherwise, it should return 0. So if it is any other character aside from lowercase, it should return 0. So what do we need to do here? We need to set an if statement, right? Here we can set an if statement. We need to check if c here is a lowercase. So I will need to say if here, I will say if c is greater than or equals to what? Or equals to a. I'm starting from a, right? I'm checking from what? Any value from a up to what? Up to z, right? And also, right, that is what and here. If you're dealing with and, this is and what, and c is less than or equals to what? Or equals to z. So as you can see here, I've now targeted everything from a to z. If c is greater than or equals to a, and also c is less than or equals to z. So now I've targeted what? The entire 26 alphabet. But as you can see, it is what? A lowercase. So it is only going to check for lowercase. So if this condition is true, what should happen? It says we should return 1. Right? So I'll just say return, and then I will add 1 here. And then it says what again? It says returns 0 otherwise. So that is the else part. So else, simply return a 0. That's also what the question says. Okay, so here, let me document my Betty. What's my function name? Is lower, right? So is lower, right? So I'll just say, sorry, checks for lowercase character, right? And then it is returning something, right? So return. So in this case, I'll just say 1 or 0. On success, it is 1. On failure, it is 0, right? So here, I'll just do this. So when you look at this here, I have what? The function is taking a parameter c. So I need to tell Betty what this c does as well. So here, after the function name, I need to create a space here for this. So to explain a parameter, you need to what? To use the at character here. So at, and then the variable name is what? Is c, right? So I will say at c, then full quote. So you tell Betty what this character does, what this parameter does here. So in c, I'll just say parameter to be checked. Right? So I'm done with this. So here I can now exit. Right? So I need to create the test file for this. So I need to copy this. Oops. What is this? All right. So copy. So I'll say vi. That is, the file name is what? 3main.c, right? So 3main.c. So I'll paste this here. I don't know why anytime I paste, I need to add the hash I here. It's not copying including that. So hash I here. Wow. Hash I. All right. So what's the next thing we need to do? The next thing is we need to compile the program now, right? Or first, let's run Betty. So Betty on our 3 is lower, right? Yeah, so as you can see, Betty is fine. So we can now proceed and compile the program. So as you can see, it has been compiled. So let's run the compiled file. 3 is lower. So as you can see, we got 0, 1, 1. So let's explain this. So when you look at this, this is where the function is being called, right? And what is passed to the function? The character h, right? As you can see, this h is in caps. So this is not part of what we are checking for. We've already set a condition that if it is not a lowercase, it should just return a 0. So that's why we are having 0 here. Do you get it? So, and here, what is passed to the function is small letter 0. So it means that what? This is a 0. And what is our function going to return? Our function is going to return 1. So that's why we are having what? A 1 here. And we look at the other case where the function is being called, which is this case here, is what? 108. So this 108 here is the ASCII code of a character, right? So let's try to find out what 108 is representing on the ASCII sheet. So let me just say ASCII sheet. Yeah. So let me open this. All right. So we are looking for what? 108, right? We are trying to find out 108 is the ASCII code of what character. So let's look for 108. Where is 108? This is 108. Did you see it where my cursor is? Did you see it? 108 here. 108. It is the ASCII code of what? Of small letter L. So it is the ASCII code of what? Small letter L. So small letter L is being represented with 108 here. So, and it is a small letter. So it means that our function is going to return 1. So that's why we are having a 1 here. Okay? That's why we are having a 1 here. Do you get it? So don't forget to add, commit, and push to your GitHub repository, and you can run your checks. So in this video, we are going to continue from task 4. So let me copy the function prototype first. Copy this. Then I'm going to paste it in my main.h. Then here, we'll just scroll down here and paste here. All right, so in fact, let me copy that of the next tasks as well. Copy to avoid always copying and pasting here. Let me just copy like 3 of them. Right? Yeah. So I think this is okay for now. All right. So let's exit, save and exit. So this is the file vi paste. So we need to include our main.h first, right? Hash include main.h. Then copy the function. We are writing a function, right? So copy and then paste this here. All right. So this says we should write a function that checks for alphabetic character. In the previous question here, we wrote a function that checks for lowercase character. So in this case, they said alphabetic. So let's look at the conditions here. It says we should return 1 if C is a letter, lowercase or uppercase, return 0 otherwise. So in this case, we are checking for both lower and uppercase. In the previous case, we checked for just what? Lowercase. Now we are checking for both lowercase and uppercase. So if the character passed here is what is a lowercase or uppercase, the function should return 1, otherwise it should return 0. So we are going to use the same if condition here. So I will say if what, just like the way we did, if C is greater than or equals to A. Now I'm checking for what? The lowercase characters first. Let me put this in bracket. And also what? And also C is less than or equals to what? Z. So now I've considered what? The lowercase characters, right? That's why I put lowercase a and lowercase z here. So now I'm checking for lowercase character. Or what? I will now say or. These two pipes here is what? Is or. Just the key above your enter key is the what? Is what is going to display this. Just shift and that key is going to display this. So or what? Or C is greater than or equals to, now I'm considering what? The capital case A, and also what? And also C is less than or equals to capital Z. So this condition here is going to check if this parameter passed C here is greater than or equals to A and also less than or equals to Z. It means it's a lowercase, right? Or if the character C is greater than or equals to capital A and less than or equals to capital Z, it means it is what? An uppercase. So it is going to check for lowercase and uppercase here. So if this condition, if any of this condition is true, so what are we going to do? We are going to return what? It says return a 1, right? Else, right? That is, if it is not any of that, we should want to return a 0 here. So we are going to return 0. That's what the question says here. So now let's explain Betty to this. So here, I will just come here. So this asterisk, so paste. So explain what is the use of the function. Checks for, and just say checks for alphabets, right? So then what again? The parameter, right? So it is what? At C, right? I will just say, let me just say function parameter. Just be descriptive enough, okay, so that anyone reading your code will understand what the code is all about. So the next thing is just return. So 1 and what? And 0. On success it returns a 1, on failure it returns a 0, right? So I'm done explaining this. So let's run Betty on this. So Betty for this. Yeah, so as you can see, Betty is happy with this. So now let's copy the test file. Copy. So vi for main.c, right? So paste. So let me do the corrections here. I don't know why it keeps omitting the hash and the I. All right, so now let's compile this program and see if it's going to work. So compile and then paste. Yeah, so as you can see, it has been compiled. So let's run the compiled file. For is alpha. So as you can see, we got 1, 1, 1, and 0. So this is what the first call to the function is a capital H, right? So that's why we are having 1, and we've set our condition that it's going to check for both capital case and lower case. That's why we are having a 1 here. And this is what? A 0, sorry, an O, a lowercase o. We are also having 1 here. The next case is what? 108. 108 is the ASCII code of what? Of L. We've just checked it here in the previous example. As you can see, small letter L. So that's why we are having what? Another 1 here. So here, as you can see, what is passed to the function is not an alphabet. It is a semicolon. So it is going to return what? A 0. That's why we are having 0 here. I believe this is clear, right? So don't forget to add, commit, and push to a GitHub repository, and then you can run your checks. So let's move on to the next task. So this task here says we should write a function that prints the sign of a number. So the function should return 1 and print plus if n is greater than 0. Return 0 and print 0 if n is 0, and returns -1 and prints minus if n is less than 0. So let's see this. I've already pasted the function prototype in my main.h file. So let me just open the file now and begin writing the code. So paste this. So what's the first thing we need to do? We need to include our what? Our main.h. So copy the function prototype and then paste this here. All right, so we are going to check, right? We are going to print the sign of a number. It says if what? If n is greater than 0, that is the function parameter. If it is greater than 0, we should return 1 and print what? Plus here. So all I'm going to do is I'll just say if n is greater than 0, right? The question says we should what? So now because I'm having what? I'm having a I'm going to write the code inside this if statement that is more than 1 line. That's why I'm adding what? A semicolon. Sorry, this opening and closing curly brace. Okay, so if you're adding just 1 line of code, there is no need for this within your if statement or your for loop. Okay, so now it says print plus and what? Return 1. So I'll just say putka here. Here we are just to use putka. Okay, let's just be using putka. We are going to use putka to print just this plus sign. So I will just say plus here. And also what should follow? It says we should return what? Return a 1. That's all. That's the condition. So the next condition is what? Else if, right? Else if, we are considering 3 conditions here. Else if n is 0, right? If n is equals to 0. Note, this is how we do the comparison. N equal to, if you are trying to compare the left hand side value with the right hand side value, you use this equality sign, not this. This is assignment. Okay, so you use this. Okay, so what next? Else if, what shall happen? We are going to print 0, right? And what? And return 0. So I will just say putka here, right? And then here I need to convert putchar to what? To a character. Sorry, I need to convert 0, right? We know that putchar cannot print digit. We've already explained that. Putchar cannot print digit. So we need to what? We need to convert that digit to character. So I can simply just do like this. I can just add the 0 within what? A single quote. I'm sure this will work as well. So the next thing is what? Is to return what? It says we should return a 0. So now we have this, right? So the next case is what? Returns if n is less than 0. So as you can see, if considered greater than 0 equals to 0, then definitely the next condition is going to be else than less than 0. So I will just say else. If you do like this, it is going to work. Okay, or if you say else inside bracket you put n less than 0, it is still going to work. But because I know that I have already considered what greater than 0 equal to 0, then we know definitely the next condition is less than 0. So I don't need to specify that here. The compiler knows that definitely you are considering the next condition, the other condition, because if you consider greater than equal to, then the next thing is what is less than 0. So here I would just say what? I would just say putchar, and then I will pass in what? The minus character here, and then here I will return what? It says return. What are we returning? A -1. Right? That's what the question says. So here I'm going to document Betty. So the file name, function name is print sign here, right? Then what's your function? What does the function do? It prints sign of a number, right? Then what again? Then the parameter, right? So I will just say at n. So let me just say function parameter, right? Then what again? Then return. So return, I will just say 1, 0, or -1. So here I will now close it. So now let's run Betty on this 5 sign.c. Yeah, so Betty is happy. So we can create the test file now. Copy this. So vi 5 min.c, right? So I need to say #i because I know it's not going to. Oops. So now it has copied including that. So I need to remove this. All right. So now let's compile the program and let's see our output. So paste. Yeah, so it has been compiled. So let's run the compiled file. So as you can see, we got the same result as this here, right? We got the same result, isn't it? So just look at this here. What was passed to the function? 98 was passed to the function, right? 98 was passed to the function. So what is the sign of 98? It is positive. So that's why I'm having plus and also 1 here. So here when 0 was passed to the function, it is what? We said that if it is 0, it should return a 0, right? And print 0. That's why we are having this here. Do you see? That's why we're having 0 and also the return value. And also the next one here is what? This is hex value of a number. I don't know what number is. And this is -1 here, right? This is -1. That's why it's printing a minus, isn't it? I'm sure this is clear by now. You understood what we just did here, right? So the next thing is to add, commit, and push to a GitHub repository. I'm sure it will run. Okay, so let's move to the next task. All right, so this task here says we should write a function that computes the absolute value of an integer. So what is the absolute value of a number? The absolute value of a number is simply a positive number, that the positive of that number. If you have a -1, the absolute value of -1 is simply 1. If you have a -10, the absolute value of that number is simply 10. Just remove the negative sign. If you have a number, let's say 20, the absolute value of 20 is still 20. The absolute value of a number is just that number, but without the minus sign. Okay, so we have to write a function that computes the absolute value of that number. So let's copy this. I'm sure we have copied the prototype already. So let's paste. So what's the first thing we need to do? Include our min.h, right? So copy the function prototype, copy, so paste. All right, so if you look at this prototype here, it's just the data type that is passed to the function here. So, and if we are to define the function now, we cannot define it without what? Giving it a variable name. So here I need to come and give it any name I want. Any name, just give it any name here. It will still work. So let me call it A here. So it doesn't matter, okay, if your prototype that is inside your header file, if you leave it like this, it will still work, because what the compiler is after is what is the data type of what of the parameter that your function is taking, and we already have it right in our function prototype. We've already told the compiler that okay, this function is taking an int, so I can leave my my prototype in my main.h like this without adding the a, while in this case, since I'm defining the function, I need to write a. Anyhow you do it, it is going to work. Okay, if you like, you add the a in your function prototype in your header file. If you like, don't add it. It will still work as far as you have the data type of the function parameter. Okay, so now how do we do this? So we need to check first if a is less than 0, that means it is negative, right? So I will say if a is less than 0, it means it is negative, isn't it? It means it is a negative. So what are we going to do? I will just say return what? How do we get the absolute value of a negative number? Assuming I have this -1, how can I make this to be a positive one? So I will simply multiply it with a negative sign. So this negative will cancel this. So I'm left with what? With just the value 1. So as you can see now, I have what? I have 1. So this is how I can simply get the absolute value of a negative number. I will just multiply the number with a minus. So what I'm going to do here, I'll just say return minus what? Minus a. So whatever the value of a is, since I'm already checking for less than 0, it means if it is less than 0, definitely it is negative, right? Any value less than 0 is negative. So if it is less than 0, then multiply that number with a negative sign. So it is going to what? Cancel the negatives out. So I will be left with what? With a. So this way I will get what? The absolute value of a returned. Okay, so next what? Else, right? That is the else. Else what? What are we going to do in the else part? That means if a is greater than or equals to 0. So what should we do? I will just say return. I'm not supposed to put this in a curly brace since it's just a single line of code. So I'll just say return a. That's all. This is going to return what? A, if the value is greater than or equals to 0. If it is greater than or equals to 0, it will just return the number, the value. Okay, so now let's document Betty for this. So what's the function name? ABS, right? Function, let me just say function to find the absolute value of a number, right? So what next? So the function parameter, I need to explain it, so which is at a, right? At a. Let me just say function parameter, right? I think it's okay this way. So the next thing is my return. So I will just say minus a. Yeah, I'll just say minus a or a. That's all. So here I just need to close this. All right, so let's run Betty on this first. 6 abs.c. Okay, it says else is not generally useful after a break or return. Okay, so it means there is something we need to do here. Instead of saying else, I will just say else if here. The reason is because I used a return statement above here. So if I just use else here, Betty will not be happy with that. So I need to specify it with the if. So else if a is greater than or equals to 0. So I think Betty should be happy now. So let's compile again. Yeah, so as you can see, Betty is now happy. So now let me create the test file for this. So vi6 main.c, right? So we need to paste this here. Oops, I'm still not having the hash and I whenever I copy this. Alright, so I think we can now compile the program. So let's compile, copy this, paste. What is it? It says all warnings being reaches the end of a non-void. Okay, I need to make changes to this as well. Here, the function is returning an int, right? The function is returning an int, so definitely I need to return something here. So it says non-void, it means the function is not void, so I need to return something. So outside the if statement, I'll just say return a 0. So I can leave it like this. So now let's compile again. Yes, so as you can see, it has been compiled. So let's run the compiled file. Yeah, so as you can see, we got 1, 0, 1, and 98. How do we got that? So when the function is being called the first time, a -1 is passed to it. So our function takes in the -1 and multiply it with a minus sign, because this -1 is less than 0. So it will be left with what? With 1, because the minus signs will cancel out since we are multiplying it with a minus. So that's why we're having a 1 here. The next call to the function is what? A 0 was passed to the function, and we said if it is 0, it is just return the value. You should just return the value. Here, if it is greater than or equals to 0, just return the value. That's why we're having this here. In this case, a -98 is passed to the function. So it is going to multiply with a minus sign and then return the value. That's why we're having 98 here. Okay, so I believe this is clear. So don't forget to add, commit, and push to your GitHub repository, and then you can run your checks. So today we are going to continue from task 7. So let me open my header file for you. So as you can see, I've already pasted this prototype. This is it here, my header file, and also the prototypes of the remaining questions as well, so that I don't need to be opening the main.h every time. Okay, so now I have this. So the next thing I'm going to do is I'll first open the file. Let me open the file first. So vi paste, then we need to include our header file, which is main.h, right? So copy this function prototype and paste here. All right, so what does this question here say? It says write a function that prints the last digit of a number. So firstly, you need to ask yourself, how do you get the last digit of a number? So to get the last digit of a number, what you need to do is simply divide by that number by 10. I don't mean you should take the divide using the divisor operator. It means I mean the remainder. Okay, when you divide that number by 10, the remainder is going to be the last digit of that number. Assuming you have 15 now, you use the modulo operator. You all know what this is. This is just to display the remainder, right? Yes, so when you do this by 10, it means that you're saying that, okay, divide 15 by 10 and display the remainder for me. So what is the remainder when you divide this with this? This is going to give you what? 1.5, right? So the remainder is this part here. The remainder is what? Is 5. So as you can see, 5 is the last digit of 15, isn't it? So what if we have something like, let's say 20, right? So you take the modulo of 10. So this is going to give you what? 2, right? Isn't it? This is going to give you 2. This is the same thing as 2.0. So what is the remainder here? The remainder here is 0. There is no remainder. So 0 is the last part of 20. So to get the last digit of any number, you simply need to what? Take the modulo of that number by 10. Whatever it returns, it is going to be what? The last digit of that number. So that's how we get the last digit of a number. Simply that number modulo 10. It is going to display the last digit of that number for you. Okay, so that's what we're going to do here. So here, the first thing I'm going to do here is I will just say I'm going to create a variable in which this variable is going to store the number. Okay, it's going to store the modulo, the remainder. Okay, so here I need to give it a value. Let me say it's just int here, so let me call it what should I call it? Let me call it I. Yeah, let me just use I. So here I will just say int k. This variable is going to store whatever the modulo of I of 10 is. Okay, so here I will now say what? I will now say k is equals to I modulo 10. So it means that whatever is passed as this parameter here, it is going to take its modulo by 10 and it's going to store it in k. So it means whatever is passed as this parameter, k is now holding the what? The last digit of that number. Because we all know what this does. This is going to print the last digit, right? This is going to get the last digit for you of I, right? So that last digit will be stored in k, isn't it? So the next thing I need to do is I need to check what if this parameter passed to the function is less than 0. If it is less than 0, it means it is negative, right? If it is less than 0, it means it is negative. So if it is negative, I want to print the number by what? If it is negative, I need to multiply the number by minus, isn't it? So that I will get the positive number, right? So here I will just say if I is less than 0. If it is less than 0, what do I need to do? All I need to do is I will now say k. Don't forget, k is holding what? The remainder, right? K is now equals to what? Minus k. So it means that it is going to multiply k with a negative sign. What this is going to do is this condition here. If we have something like minus 15, right? Minus 15 is less than 0, isn't it? So minus 15 modulo 10, what is this going to give us? This is going to give us 5, because 5 is the last digit here, right? This is going to give us 5. But actually, we are not supposed to get 5 here. We are supposed to get a minus 5, because the number itself is containing a minus, right? So that's why I did something like this here. I multiplied it with a minus sign now. So instead of it to just return k, it is going to return what? Minus k. Because I've multiplied the k with a minus. That is if I is less than 0. If the parameter passed to the function is less than 0. Okay, so it is going to do this. So the next thing is what? We add a new line, right? Put after printing all these things. No, we need to print it now. Okay, now we just have this thought, so now we need to print it, right? We need to print k. So here I will just say k, right? I can use putchar to print k, but hold on, when you look at this, k is what? Is an integer. So the value that k is stored in here is an int, isn't it? It is an integer. So how can I make this to be a character? Because we know that putchar can only print character. So to get putchar print character, after passing the variable that holds the integer or the digit, you simply add plus, and then you add what? A 0 in a single quote. So this will convert this digit here into what? Into a character, and it will be printed by what? By putchar. I'm sure you know this already. So the next thing is what? It says print the last digit of a number, and also the returns the value of the last digit. So we should return the value of the last digit. So what variable is holding the value of the last digit? K is holding the value. So I'll just say return. I will now pass in k here. Okay, so now the next thing is by Betty documentation. So I'll just say Betty. So the function name is print last digit, right? So the next thing is the parameter, right? At I. So let me just say function parameter, and then what again? The return, right? So return, I will just say key. Yeah, so I'm supposed to add this. All right, so let's run Betty on this 7. Okay, initial short description of what? Okay, seems like I missed something. Okay, yeah, I did not explain the function here. So what does this does? Prints last digit, right? So I think this is fine now. So let's run Betty. Yeah, Betty is fine. So the next thing is what? We need to create the test file here. This is going to test if our function is working the way it's supposed to. So copy this. So vi, this is 7 main.c. So paste. Let me make this correction quickly. #I. All right, so let's compile and let's see if this will work. Copy, paste, enter. Yes, it has been compiled. So let's run the compiled file and let's see. Yeah, so as you can see, we got 8044. So why are we having it here? Because 98 was passed to the function initially. The first call to the function was holding the value 98, and what is the last value of 98? It is what? 8 here. So that's why we got 8 printed here. So the next one is what? Is 0, right? What is the last value? It is still that same 0. And here, what is the last value here? Is 4. 4 is what? Is displayed here. So this 4 here you are seeing is because the function entirely, the function itself, is going to return the last digit in which it is holding. So this is the last digit. This is the digit in which the function is holding, that of this 98, 0, and also 1024. So we have what? 804, right? So, and what is the last digit of 804? The last digit of 804 is still this 4 here. So that's why we are having an extra 4 here, because the function itself is returning its own last digit. So the last digit of this 804 is what? Is 4. That's why we are having this extra 4 here. Okay, so I believe this is clear, right? All right, so let's move on to the next task. Don't forget to add, commit, and push to a GitHub repository and run your checks. I'm sure it will work. All right, so let's move on. So this says we should write a function that prints every minute of the day of Jack Boyer starting from this to this. So this is asking us to print every minute of the day. Okay, and as you can see here, this is what? 12 o'clock, right? This is 12. This is a 24-hour clock here. 12 o'clock, and this is what? 11:59. So we know that this part here before the full colon is used to keep track of what? The hours, right? And this is used to keep track of what? Of the minutes. So this means what? 23 hours 59 minutes, right? So one thing you need to understand before approaching this question is that you know that this represents the hours, this represents a minute. So it means that you need a what? A loop, a nested loop, in fact. So the first loop or the outer loop is going to keep track of the hours, and the second loop or the inner loop is going to keep track of the minutes. Because what we normally do is for each increment in the hour, the minute has to go 59 times, right? We don't have 60 minutes. It's from 0 to 59. So 59 is the last, is the range. While for the hour, it's going to stop at what? 23, since we are considering a 24-hour clock now, right? So just take note of that. This is going to be represent the hour, and this is what the minute. So we need a loop within another loop. The outer loop is going to represent the hour, and the inner loop is going to represent the minute, isn't it? So now let's open the file first. Copy vi and paste. All right, and also before we proceed, how do we get the first digit of a number? We've already seen how to find the last digit of a number, right? So how do we get the first digit of a number? So let me explain this as well here. So to find the first digit of a number, instead of using, assuming you have 15 now, instead of using the modulo operator, you simply use the divisor operator here. This divide by 10. So you know that this is not going to display the remainder. That's what this operator does. It will just print the whole number. It will not print the remainder, right? So what is this going to give you? 15 divided by 10. It is going to give you what? 1. It means 10 is going to go into 15 1 times. It will not return the remainder. So this one here, as you can see, is the first digit of what? Of 15. So to get the first digit of a number, you use the divisor operator. To get the last digit of a number, you use the what? The modulo operator. Okay, so now if you understand this, then fine. So now let's include the header file first, #include main.h. right? So let's copy the function prototype, copy this, need to paste this here. All right, so what's the first thing we need to do? I said we are going to need two loops, right? For the hours and for the minute. So I will say int I, comma g. So now I have I and g now. A loop for I, sorry, the variable I'm going to use to look for the hours and the minute. So the first loop is going to be a what? The loop for the hours, because it is the hours that we need to increment first, right? If the hours increment, then what will happen? The minute will go from 0 to 59 times, isn't it? So what I'm going to do here is I will just say for I, right, equals to 0, since we are starting from what? From our 0, right? We are starting from our 0. For I equals to 0, what should be the condition? I should be less than what? What is the last level of the minute? The last number for the hour, sorry, is 23, right? So I less than 24. It means it's going to consider from 23. Right? Then what? Then I plus plus. So now I have this loop. This loop is going to keep track of the hour. So, and what do we want to do? For each increment of the hour, for each change of the hour, we need the minute to go from 0 to what? To 59. So here I will create another loop. I will say for j equals to 0, what should be the condition? J less than 60 in this case, right? That's the condition. Then j plus plus. That is for the minute. Is because we cannot have minutes that exceed 60, and we cannot have minute that is equals to exactly 60, right? It stops at 59. So what's the next thing we need to do here? So inside this now we can do our work here. This is where we need to do the work. I hope you understood what this loop is all about. The first loop is keeping track of the hours, and for each iteration of the hour we want the minute to be printed how many times? 59 times. So the next thing we need to do is to print the hour and the minute. So we need to print the hour then we print this full colon, then we print the minute, right? But the first thing we need to do here is we need to first print this number, right, which is the first digit, and then we print this one, which is the last digit. We cannot print them both at the same time. We can't. Using Putka, we cannot. Okay, using Putka, we cannot print them at the same time because Putka prints what? A digit and also a character. So we cannot print a character. We cannot pass this as a character because, as you can see, it contains more than one digit, which is 0 and another 0. So it means we need to split this. We need to first print the first digit, then print the second digit. And I just explained how to print the first digit of a number. We simply use the divisor operator and divide that number by 10, right? So here I will just say Putka. I'm now printing the hours first, right? I need to print the hour just like how it appears here. You need to print the hour, a full colon, and then you print the minute, right? So I say Putka. So what am I going to print here? I will say I divide by 10. So this will get the what? The first digit of the hour for me, right? That is this first digit here. So I will now say plus. Since I'm using Putka, I need to convert it to a character, right? So I will say plus, then you add a 0 within a single quote. So this will convert it into what? Into a character. So the next thing is what? We have now printed the what? The first character of the hour, right? For the first digit. So the next thing is to print what? The second digit, right? As you can see, I'm highlighting it over here. The next thing for us is to print the second digit. So I'll just say Putka here. Then I'll say I. Now I'm going to use the modulo operator because the modulo operator is responsible for getting the last digit of what? Of a number. And this is the last digit of I, isn't it? Then I will also convert it to what? To character. So now I have the hour printed. This will print the hour for me, the first digit and second digit of the hour. The next thing is to print what? The separator here, which is what? Which is a full colon, right? Just look at this. It is a full colon. So I need to print it. So I will just say Putka, right? And then I would pass in what? The full colon here. So now this will print the full colon. So the next thing is for us to begin printing the minutes. Also for the minute, we need to print what? The first character, then the last character. So I'll just say Putka. So in this case, I'm going to use J, right? Since J is responsible for keeping track of the minutes, right? J divided by 10 plus 0. So this will print what? The first digit of J. So the next thing is to print the last digit of J, which is J modulo 10 here. So I will also say plus 0, right? So now I have this. This is going to print the hour, then this is going to print the separator, and this is going to print the minute. So this way I will have all the minutes printed. Okay, so what this is going to do is for the first iteration, which is I is 0, so it will jump, it will check is I less than 24 years, then it will jump into this loop. J is equals to 0, J is less than 60 years, so it will print whatever the value of the first value of I is, and also it will print whatever the last value of I is. Then it will print this, and then it will print that of J as well. So this way we will have the time, the hours, and the minutes printed. Okay, so now the next thing is what? Betty documentation. So let's document Betty. Right, so this is going to be Jack Boyer, right? So let me just say print every minute of the day, right? So the next thing is what? No parameter, so I'll just explain the return value. Return, so here I just say void, it doesn't return anything. All right, so let's run Betty on this. Betty 8, yeah, so Betty is fine with this. So let's create the test file to test this function. So copy vi8 main.c. all right, so let's paste. So hash I. All right, so let's compile the program now and see if we will get the desired output. All right, so let's run the compiled file. Whoa, so seems like we're missing something somewhere. Let's go back to our file. I believe we missed a space, a new line. Yeah, so after this, after printing as you can see, after printing the hour and the minute, for each minute it goes to the next line, right? So we need to add a new line here. So here I will need to call putguy again and then pass in /n. So this is going to print a new line. After printing each minute, it is going to print a new line. So let's check this now. Let me clear, compile. So let's run the compiled file. Yeah, so as you can see, we have every minute of the day printed. If you can scroll up, it's going to be a very long output because we are printing every minute of the 24 hours we are having. So it's going to take a very long time for us. So what we're going to do here, just like their own, as you can see here, when they called the function, they pipe it into head, and we all know what head means. This is going to display the first 10 output, right? So let's check this as well. If ours is going to display the first 10, let's just compare the first 10, because they know that if they are not to filter and print the first 10, it is going to be a very long code as well. So let's check. This is our own first 10. Just look at this. We have from 00 up to 09 the minute. So it means we have the first 10, right? So let's check the last 10 as well. So instead of using head, I will just say tail here. So this is the last 10 as well, 2350 up to 2359. So it means I have I have the last 10. So now let's count the number of lines, right? As you can see here, we have 1440 lines. So we need to count the number of lines as well. So let me just call it, then I will pipe it into word count, right? -L, it means only count the lines. So yeah, so as you can see, I have 1440, the exact number of line as the output here. So it means my code is correct. So since we've run Betty is happy, I'm sure this is correct. So don't forget to add, commit, and push to a GitHub repository, and then you can run your check. So we're going to stop the session here. From the next video, we are going to begin from task 9. So thank you very much. To meet in our next session.